the expected value. Now, going back to that Gregor Mendel screen where I found the mean number of green peas, where was it? Right here. When I found the mean number of green peas to be 6, what did I say about that 6? What does that actually mean? And that's a different mean than this mean. I said that's how many he would expect. If he went out and grabbed 8 peas every morning for 10 years, this is what he would be expecting. So it's not surprising then that the formula for expected value, if you look back to the picture of the scared llama or the confused llama, that's the same formula for the mean of a probability distribution, because those two things mean the same thing. The expected value is the mean. So sometimes I may say, find the mean of this probability distribution. Sometimes I may say, find the expected value of this probability distribution. You just have to understand those are two different ways of saying the same thing. So you could put right here that, if you thought it would help. The mean is the same thing as the expected value. Miss Tiffany, smile. Life is pretty good. All right. Last problem in 5.2 is expected value. And I have to go, wait, that means the same thing as the mean. I'm going to sell a bunch of life insurance policies, and I want to know what to expect for the profit for my company. If I can set up a probability, see, it didn't give me a table here. I'm going to have to come up with my own table. But if I can come up with a probability distribution, then I know how to put that in list 1, list 2, and find the mean. And the mean's the same thing as the expected value. So the hard part of this problem, two things have to trigger in your head is, hey, this means make a probability distribution. And second thing is, and find the mean. I think those are good enough words to put right here. Ooh, I'm glad you said that. I'm glad you said that. Let me finish writing this sentence and I'll answer you. Make a probability distribution and find the mean. Because mean is the same thing as expected value. From here on out, we're going to do almost everything we do on a calculator. I can think of 2 formulas the rest of the semester that we don't have a button for on the calculator, and we're actually going to have to enter some stuff by hand, and that's fine. But my math lab, because it was written for teachers who do show calculators and teachers who are mean, I take that back, they're not mean, they just want you to really, really get it. Teachers who don't use a calculator, everybody listen to this is important. From now on, View Example is going to show you how to do it by hand. And if one of you emails me and says, ooh, I wish I could get to that llama real quickly. If you email me a picture of yourself and you look like that llama because you're trying to use the formulas, I'm going to say, stop trying to use the formulas. You can do this on the calculator. Now, what it's good for, Ashley, is you can check and make sure you have your probability distribution set up right. Or on some other problems, you can make sure that you've chosen the right variable, the right value for all the variables. But when they start talking about doing this formula by hand, click out of View Example. We're not going to do it. Unless you just want to. And you can. That would be okay. All right. see what this problem is about. There is a 0.9968 probability that a randomly selected 50-year-old female lives throughout the year. That makes me really happy because I turned 49 last week. If I make it to one more birthday, there's a 99.68% chance that I'm going to make it to one more birthday. All right? I'll make it. If I make it to 50, I'm probably going to make it to 51. Not 100% sure, but probably. A Fidelity life insurance company charges $226 for ensuring that the female will live throughout the year. Now, let me give you a spelling lesson here. This insuring is buying insurance. What's the other insuring? With an E, that would mean they're going to make sure she lives. Well, they can't make sure she lives, but they can sell her a policy in case she doesn't. That's the insuring with an I. So the company's going to charge $226 for ensuring that the female will live through the year. If she does not survive the year, the policy pays $50,000 as a death benefit. So if she dies, family's getting some money, but they're too sad to spend it. Okay? Don't think everybody's dancing around because this 50-year-old woman died. Let's make a probability distribution. What are the possible outcomes for this woman in the upcoming year? What are the two things that one of the two is definitely going to happen? She's going to survive or she's going to die. That's the only two things that can happen, nothing in between. So I'm going to make my probability distribution. I'll have to write small, but my probability distribution always has the possible outcomes in the left column and the probabilities in the right column. And if I want to label this even more clearly for myself, I can say, this is the event where she lives. This is the event where she dies. What is X going to stand for here? What? Those aren't numbers, though. X can't. What? Those are numbers, so you're getting warmer. Tell me words for the numbers you just said. You're talking about the probabilities. The probabilities go here, and we will put them here, but that still doesn't tell me what X is. Binary system, computer programming. Yeah. No, it's the amount of money. It's the possible outcomes. If she lives, she's actually going to lose $226. She paid $226 for the policy. So if she doesn't die, she's just out $226. Is she sad about that? No, I'd rather be out $226 than be dead. Miss Ashley? Yes, and she can renew it every year. Every year she can decide whether to pay $226 for next year. But as she gets older, it may go up. Yeah, it may not always be $226. All right, so this X value is the, let's say, monetary value for each outcome. If the outcome is that she lives, then the monetary value is negative 226. Now, I only know this because this problem said from the perspective of the female. From her perspective, living has a negative monetary value. If it said from the perspective of the company, and she lives, they would have made money. They would get to keep her 226. But since this says from her perspective, living is a loss of money that we're gladly give up. Now, while we're working on our X's, what's the monetary value of her dying? $50,000. She still spent the $226. Ah, man, nothing in real life is simple. We left simple behind in algebra. If Bob is 3 years older than his brother Joe, we've got to say, I'm trying to assign it some words so it'll make sense when you look at it at home, because I know you look at it at home. Net value of dying. I hate to call it that, but that's what it is. Yes, the estate gets $50,000, but $226 was already taken out of the estate. So really, the net value is $49,774. Watch out for that. $49,774 is the actual change in the estate's value that year. Everybody okay with both of those X's? All right, what about the probabilities? What is the probability that she's just out $226? That 99.68%. She's probably going to live, and so she's probably going to lose $226. What's the probability that the estate gains $49,774? And where did you get that? There's only two possible things that can happen. If there's 99% chance of living, then there's a 1% chance of dying. These are complements of each other. These are the only two things that can happen. So 0.0032 is the probability that the estate is going to gain $49,774. Another thing that I know is if this is a probability distribution, these have to add up to 1, and that tells me how to find that one. Subtract this one from 1. All right. Is that a good probability distribution? We have the only two possible outcomes. These two probabilities add up to 1. And each one of them individually is between 0 and 1. So I've been working this problem so long, I don't remember how to find expected value. What do I do? It means the same thing as the mean. And how did we find the mean? Somebody say One Bear Stats. It was stat, calc, and then One Bear Stats. We have to, because otherwise we would be indicating a gain for the estate either way. See, actually, sometimes some problems, negatives don't make sense, but in some problems, negatives do make sense. All right. Ooh. It's so much easier to enter stuff on the calculator than it is to use a mouse to enter it. I'm going to use that for my excuse for why I'm so much slower than you. I'm using a mouse. Oops. Yep. Got it. See, Miss Ashley, email me if you need me this weekend, and look for an email from me when I hear from my dean. I will be checking. All right. Do I have that entered correctly? And how do I find the mean? Stat, calc, and number 1. Let me clear that. Stat, calc, and number 1. And then I'm going to tell the calculator, I want you to use my list 1, comma, my list 2. And which one of those numbers is the expected value of this, let's say 1,000 policies are sold. What's the average gain or loss for each woman? On average, each woman will lose $66. Now, actually, you can't lose $66. You're going to either lose 262 or whatever it was, or you're going to gain 49. There's really nothing in between. But the average of 1,000 policies would be a $66 loss. You could put, it just depends on how my math lab asked the question. If it says, what is her expected value, you would put negative 66. If it was multiple choice, you'd probably say it's a loss of 66, because those two things would mean the same thing. Yes, ma'am. Double check your numbers then. Just about the only way you could have something different is if you transpose two numbers in your stat editor. Did you have the negative with the 226? That's easy to do. Easy to do. Now again, this $66 loss is from the perspective of the woman. From the perspective of the company, what is the expected value? If every woman loses $66, then the company is going to get that $66 for each policy. So that's how they decide how to set policy premiums. You take the probability that you're going to live or die and decide how much profit you want to have, and then adjust the premium accordingly so that that expected value is what your company wants it to be. Yes, ma'am. Absolutely. The probability that an 18-year-old will crash versus the probability that a 30-year-old will crash. And that's why insurance is cheaper when you're 30. Exactly the same thing. Probability that you don't go to the doctor versus probability that you do go to the doctor. Right. They've broken, I mean, they can't say with any degree of certainty whether you're going to have to be in the hospital. Right. But they do consider risk factors. You know, if you check the box, yes, I'm a smoker, then your policy is going to be higher because the probability that you're going to have both lungs removed is higher. Yes. I think the evidence is there.
Well, yeah, I mean, that's an obvious one. Yeah, I know that much. Like, for example, let's say it's I have a Porsche, and it's Bob that has a Ford truck.
The Farm Bureau has a computer program that spits out Bob's probability of crashing versus your probability of crashing. I don't know what all factors go into that program, but I can tell you that the career that does all of this number crunching and predicting probabilities, that's called an actuary. That is one of the hottest fields hottest fields going. As life gets more complicated, we want more people to tell us the probability that things are going to be okay, or the probability that things aren't going to be okay. That's what an actuary does. And I mean, if you like statistics a little bit, pursue it. Either you'll come to like it more or come to decide that's not what you want to do. Engine.
If a guy is married versus a girl that isn't,
the formula would be very complex, and that's why it's a computer spitting out those probabilities and not somebody doing it by hand. Okay, I was just going to say, if this said from the perspective of the company, then that would be a gain of 66 instead of a loss of 66. So can the company expect to make a profit from these policies? Yes. 66. Ooh, that looks like a negative. Let me draw an arrow. Yes, $66 per policy. So if they sell 1,000 of these policies, they're going to make $66,000. It's not bad. They're going to have to pay the families of a few women who died, but still all the 262s they collected outweighed what they paid. And that's the only way insurance can stay in business. All right. There's a problem like this in the homework, and it has one other part. Let me just call it, I'll tell you what it's going to say and how you'll figure it out. It says, what should the policy cost if the company just wants to break even? Yeah, using everything we've already done. We don't have to redo any crunching. We just have to think of how to get this answer. This is one of the worst problems to click view example. The first time a student said, I don't know how to do the D part, I was thinking, well, gosh, I don't either. So I clicked view example, and I have a master's in math, and it didn't make any sense. Or it did eventually, but it was the hardest possible way to figure out something that really is simple to do. Can anybody think of the simple way to figure out what the company should charge if they don't want a profit, if they just want to break even? It would be nice if Obamacare just broke even. How much would you pay for the policy? I want you to click view example just to see how difficult they made that. If at $226 they're making a profit of 66, then just charge 66 less and break even. I just want you to see. I want you to click that view example button and then write the editor. 226 minus 66 is 160. So if you charge 160, the company will break even.